So we started by stating that experimental error would be any sort of difference between a true or accepted value and experimental values. We will go on to further redefine experimental errors in terms of what may actually happen in an experiment, and an error can be classified as systematic or determinate, or random, that is indeterminate error. We're going to go on to talk about random errors in more detail, and we're going to jump right in with our definition of a random error. Now, by the term random, it should mean it is any error which occurs in an experiment which is uncontrollable. Now, this is inclusive of any fluctuations in a measuring apparatus, for example, an electronic balance, a pipette, a burette. So any fluctuation or differences in your experimental values can result from a random error, where this random error is inherently due to the experimenter himself or herself, where there's an inability to take the same measurement twice in exactly the same way. So we're just going to continue and use our definition of random error as is, and we're going to try to understand what it means by looking at examples of random errors. So a random error could be the operator who has to visually judge readings on, let's say, a pipette or burette or beaker, right? Two operators may not see the exact same value. It may be temperature fluctuations in an environment, which may affect the density of a liquid. It may be air drafts within an electronic balance, and the presence of air drafts in an electronic balance is also due to the experimenter in the use of that electronic device. So we say that random error is a source of experimental error, and we're going to go on to look at how does a random error affect the accuracy and or precision of the experiment. So if random error exists in your experiment, let's look at what the degree of random error would mean. If there is a low amount of random error, this will be seen in the closeness of the values obtained. Where the values are close together, which will show a high precision, that indicates low random error. However, if there is a large amount of random error, this will be seen in a large spread of values, which is a low precision, and this is the difference between low and high random error. Now consider if your experiment contains random error, it is said that it is always present and cannot be corrected. However, there is an advantage of random error where we say it is possible to reduce the amount of random error in an experiment by replicating the experiment, that is, by repetition or replicate measurements. Random error can be reduced in an experiment. So once again, random error can be reduced by repeating an experiment, for example, repeating a titration. So the precision of an experiment can be improved. Now let's move on to looking at systematic or determinate error, keeping in mind random error affects precision, so that means systematic or determinate error will affect accuracy. Let's start with our definition of what is systematic or determinate error, and it is considered to be a consistent difference between a measurement and its true or accepted value. That means systematic error or determinate error should be easier to identify because it is consistent. Now let's look at some examples of systematic errors to clear up what it is. systematic error may be instrumental, method, or a form of personal error, where instrument error is inclusive of an electronic instrument which may be calibrated incorrectly. Let's say it's your electronic balance, your pH meter, your UV-vis spectrophotometer. A burette or pipette may be incorrectly calibrated as well. Instrumental errors are also inclusive of a low voltage or power supply to the device. And it is said that instrument errors are supposed to be easy to detect and correct because, as it says, it should result in a consistent difference between a measurement and its true value. Next up, there are systematic errors which are called method errors, which can occur in an experiment. It may be incompleteness of a reaction, there may be side chemical reactions occurring, or one that you would be aware of, which is called a titration error. And what is titration error? It would be one which is the difference between the stoichiometric endpoint and the endpoint obtained in a titration. Now, instrumental errors, being easy to detect and correct, are different from our method errors, which are difficult to detect and correct. But they do result in a consistent difference between a measurement and its true value. Next up, there are personal errors, and personal errors can be classified as mechanical loss of materials by the experimenter, the ability to detect color change, for example, in a titration, which may result in overshooting of the titer value. In gravimetric analysis, it may include underwashing or overwashing of a precipitate. It may include igniting the precipitate above a temperature, which may result in decomposition of the precipitate, right, above its melting point. It may be insufficient cooling of a crucible before weighing. So these personal errors are also considered to be systematic error because it can result in a consistent difference between a measurement and its true value. Now keep in mind here, systematic error is a consistent difference and random error is an inconsistent difference. Later on, we are going to look at titrometric analysis and gravimetric analysis and classify the type of errors which occur in both experiments in terms of systematic error. So on that note, let's just wrap up systematic error in terms of looking at what would be any advantages of a systematic error versus its disadvantage and what is the consequence of this type of error. We say that systematic error, because it is a consistent difference, it can usually be detected and corrected. Systematic error, as stated before, does affect accuracy. It can result in a positive or negative bias. That is, the experimental values obtained may be higher or lower than the true or accepted value. If there is a low amount of systematic error in your experiment, you would be able to note this as there would be a high accuracy, meaning there is no large amount of positive or negative bias in the values obtained. They would tend to be very close to the true or accepted value. However, if there is a high amount of systematic error, this would lead to low accuracy, where the values obtained may have a positive or negative bias. That is, they may be higher than or lower than the true or accepted value. Right, just to recap, random error affects precision, systematic error affects accuracy.